Welcome to video number 23 workshop on nonlinear regression function using STATA. You can watch video number 13, video number 19 and some earlier videos which were related with workshops on OLS and workshops on testing of hypothesis. So here we are going to read data first. You can read this data from Excel, you can read data from STATA, you can read from other softwares. So first of all, let's change our working directory so that our results will be stored in that working directory. For convenience, I'm keeping desktop as my working directory. And as I mentioned in my previous workshops, that our main data is California school data, and today our topic is nonlinear regression function estimation. So first of all, we are going to describe variables. So DESC, so you have all these variables, float, string and all that. Our main variables of interest were so far test score, student-teacher ratio. Today we are going to focus on average income, and previously we have English learner percentage, calorie meal given at schools or not. So our research question today, which we are going to complete the answer of that question, or you can say we are going to end up this question, the answer of this question, that is, does class size reduction lead to improvement in test score and by how much? We'll see various specifications of the model, and we'll try to pick the one which is the best one. You have many candidate models, and we'll try to pick the one which is the best one. So let's start, and instead of doing all these lengthy calculations here, for example, we need to calculate some more variables, and for generating a variable, you can write the whole term generate or the first three letters average income square. So we need to generate this variable average income into average income. So that average income square is calculated. Similarly, you can generate average income cube variable because that is also needed. Similarly, we can generate log of income. So instead of doing all this during the video, we have this do file which we'll discuss at some other time, and you can have this do file. So at the moment, I am going to generate these variables from here. I have all these commands here, so you can. Okay, fine. We have all these commands here. So if you have listened my videos on nonlinear regression functions explanation, their conceptual understanding, our first equation was to regress test score on average income. Okay, this was non-linear function. You can look it into this way, two-way scatter test score AVGINC AVG. Okay, and let's we fit a linear fit test score AVGINC. I hope done the things correct way. Yes, it seems so. So you have this one linear fit, but we want a non-linear fit. So what to do? Let's have a loss command recall, and you can go for this Q fit, quadratic fit. So that seems a better fit, so we may go with quadratic fit, or we may go for cubic fit. So I am going to regress test score on average income square, which the variable we have already calculated above, average income. Okay, and for heteroscedastic corrected standard errors we use robust. So you see we have adjusted R square 0.55, root mean square error, and all these terms I have already explained. Now I am going to compare it with another model where you can have average income cube. So whether cubic model is okay or quadratic model is okay, that we are going to look into. So you see in this case all variables are significant. In this case you have this variable which is significant at 5% level. Your adjusted R square is 0.55, here 0.55, root mean square error is 12.7. So there is a very little difference between quadratic and cubic, and in cubic you have 1 degree of freedom consumed more than quadratic model. So if I were you, I would have picked quadratic model. So in this way you can play around with these models. At the moment we are going to basically answer the question. So you have a cubic, polynomial, quadratic, linear, and you can compare linear versus quadratic versus cubic, and on the basis of different statistics criteria you can pick the one which you think is the best one. Now we are going to answer the question. What was our question? Whether class size reduction leads to improvement in test score or not. So we are going to generate some models, and allow me once again, instead of taking lot of time, I am going to regress it from do file so that our time is saved. You can skip this. You can find out similar type of do file from the Stock and Watson website, Introduction to Econometrics Student Resources. So I am going to basically regress this one, EST out, and we have this model. Okay, we have this student teacher ratio, test score is regressed on student teacher ratio, English learner percentage, meal percentage. This is what we have discussed so far in multiple linear regression in chapter 6 and 7. Today we will add something more. Here we are going to add another variable, that we have a log of income as well. So log of income we haven't included so far. So you have again log of income, and these results are stored in EST2. I have used here EST-STO2, EST tab. Basically this will help you to generate columns in a nice way to be placed in Excel, Word, or some other software. So we have another variable where we have regress student teacher ratio. Okay, we have here generated a variable high English learners. This is a binary variable, that whether you have more than 20% this variable I have calculated here. High English learners. High English learners, if you look here, that if English learners are more than 10% in your class, then it's 1, otherwise it's 0. High student teacher ratio means that if student teacher ratio is more than or greater than or equal to 20, it's 1, otherwise 0. So we have here included high English learner percentage and interaction, which I have explained in my last video number 22. Student teacher ratio into high English learners into their combination, so that you can see that whether it's student teacher ratio or it's high English learners or it's both. So you can run these models. Okay, again I have another model. We have regressed so far 3 models. Please be with me. We are going to finish it shortly. I am not doing each and every calculation here. So we are going to add another variable here. So why we are doing all this, adding more and more variables? Basically we want to see whether student teacher ratio really affects test score when all possibilities, all relevant variables are consumed in the model, are included in the model. So you have this here, you student teacher ratio square, student teacher ratio cube, high English learner, mean served in schools are not too poor, and log of income. And I'm going to finish it very soon. I'm going to generate 2 more regressions. and you can look into these regressions, and you see all these regressions are displayed in front of you, and you can download this do file as well from the Stock and Watson Introduction to Econometrics Student Resources. So you can see this is the command which we have been regressing for several variables. Fine, that's okay. We have basically tried 7 models. We have 7 models, and we'll try to pick the one which best explains the phenomena. So you have 7 candidate models. All these models may be correct models, but which one is the best? That you need to pick from theory, you need to pick from statistics, you need to pick from common sense and all that. Okay, now we are going to generate columns as usually it's generated in Excel, to make it a column, column 1, column 2, column 3. So what I'm going to do here, I'm going to write down ESTTAB, standard error and adjusted R square. You see, that's how you can use these columns, and now you have adjusted R square for each model. Adjusted R square for each model, and number of observations and standard errors are in parentheses. So in first model, we have included student teacher ratio, English learner percentage, and meal percentage. Second column, this one, all variables are significant. Look at third column. In third column, your high English learner and this interaction term are not significant. So it means these variables are redundant. These should not have been included. So these are not significant. Whereas in column 4, this again, these two variables are not significant. But please keep it in mind, if interaction term is significant, then you must keep main variables in the model, whether they are significant or not. So here you have column 5. Oh, in column 5 you have lot of significant variables and constant. In column 6, okay, don't interpret it student teacher ratio only, because student teacher ratio square and all those variables are included as well. So here if you go and read chapter 8 from Stock and Watson, so I will be with column 5 or column 7. You can not only on the basis of only statistical criteria, but on the basis of common sense and labor economics theory, that whether class size affects test score or not. You can use these variables. You can reproduce this data by, I don't remember exactly the command for producing this in the R, but it in Word, but you can use .rtf or .xlsx. So this table will be produced in Excel or in Word. So please, what I am going to say here, that you need to practice this. Until and unless you practice it, you will not learn it. You will think you have learned a lot, but you do this practice and read theory. So I have completed from video number 1 to video number 23, chapter 4, 5, 6, 7 and 8. 5 chapters. If you want to learn econometrics, please read these 5 chapters from Introduction to Econometrics, Stock and Watson, and beside that, if you like, you watch these videos, you have one of the best, you will be one of the best in understanding up to multiple linear regression models. Thank you for watching. Take care.